I want to do hopefully a quick one about this little board preheater that I found on eBay. It's a HAKKO FR820 ESD safe, as all these HAKKO things seem to be. Yeah, I'm trying to learn a little bit of BGA or ball grid array surface mount rework. And HAKKO makes really nice soldering equipment. This one was listed as broken or not working on eBay, and I got a screaming deal on it, if I can get it working, especially. So it just said, the listing just said turns on, but no heat. So I'll take you around the outside really quick before plugging it in. Zoom out a little bit. Yeah, so power on, off in the front, and you've got some kind of adjustable temp with, I guess, 4 approximate ranges. I don't really have a super accurate like thermocouple or anything like that to measure temp, but in theory, this could serve pretty well at various heats. And we've got a start-stop there. I was considering getting an IR board preheater, like the Chinese model T8280, I believe is the model number. That one is really popular with DIY repair people. And I saw that this was an option for a preheater, and the board that I want to work on is pretty small. And it's hard to tell, but this thing is really small. Like, it's maybe 5 inches by 5.5 inches, and maybe 2 or 3 that way. It's kind of endearing how small it is. Well, you clicked on the video description. I'll go ahead and plug it in and see what it does. Okay, so turn on pilot light. And nothing over the heater, so let's just turn on to 150 degrees Celsius and hit start. Pilot light goes out. And I've actually got a small amount of air coming out of the top, it feels like. Yeah, and I can hear a little fan in there going. No heat. The start-stop button toggles the power light. We've got a flickering light there. No heat as far as I can tell, and no glowing in the coils, at least at 300 degrees Fahrenheit, 150 Celsius. I'm going to imagine that the pilot light comes back on when you hit the desired temperature, or at least what the unit thinks the desired temperature is. So, it sort of flickers when I turn it back down low. I think you should be able to see that. Up high, max heat, turn it back down, nada. Okay, maybe a blink. Okay. Well, it's very quiet, so if we can get it working, maybe we'll have a nice, quiet little board preheater. The T8280 is the next most likely thing that I'd get for this project, and that one has a very noisy fan in it, without some modification. And yeah, if I can get this working, then that would be sweet. Tested good, tested bad. I guess there's a line through both, but it says powers on, no heat. Tested by that person back in May. There's some of the specs. I should have taken you around it before turning it on, but yeah, there's all the info. Made in 2007, looks like. Now, and there's got this interesting little panel on the bottom. I suppose that's to keep things from getting stuck in the fan or something like that. Just say, can you see that okay? That sort of raised fan grill, and then also a little protector over it. Perhaps that's also for heat or for board drippings, or perhaps flux dripping down through the coils and stuff like that. Okay. Well, the idea with this thing is that you just have a board like sort of mount and then you can sort of just lay it underneath where you need to do rework, in theory. And it looks like it has been used, obviously. There's like little bits of flux that I'm able to take off with my fingers. So I'm going to go ahead and pull up the manual for this thing and tear this guy open and start doing some testing. All right, we've been trying to get some kind of a repeatable error out of this thing, and so far I'm not really seeing one. I've got the owner's manual pulled up here, available on HAKKO's website. So we've got some good info, such as error indication, when a fault is detected. In theory, the lamp on the front panel flashes in the following pattern, indicating a fault occurs. Heater error looks like a repeating flashing light. When a heater fault is detected, the lamp flashes at equal intervals as shown to the left. Sensor error, lamp flashing pattern is 2 flashes, looks like, yeah. When a sensor fault is detected, the heater is forced to be turned off and the lamp flashes in a pattern of 2 blinks as shown to the left. Fan error, when the fan fails to speed up within a given period of time or the fan speed drops below a certain level during operation, the lamp flashes in a pattern of 4. Okay. We've also got a troubleshooting flow here, or not necessarily a flow, I suppose, but yeah, unit does not operate, blah, blah, blah. Now, the weird thing is I can't seem to get, I have actually gotten a couple of repeatable error-like codes or beep codes out of the thing. I was able to see a heater error reported, and then I think I might have seen a beginning of a sensor error, but I think it's kind of confused, whatever's going on. So I'm trying to think of what might cause an issue here. Additionally, let me scoot down a little further. Okay, so heater / sensor information. This is in the owner's manual. It has the entire sort of layout of the thing. It's got all these parts, so sensor connector, heater connector, and these are 2 parts of troubleshooting. So you can measure the resistance of the heater to, I guess, verify a fault there, or measure resistance of the sensor. So heater resistance, we're in 110 to 120. Let me double check that. We are expecting 25 to 30 ohms across the heater resistance, so we can literally just unplug this connector, and we'd expect to see 20 to 30 ohms across that to test the heater, in theory. And further down, measure this resistance of the sensor. Looks like we're expecting 0 ohms there. If the sensor value is different from the above figure, replace the sensor. Okay, and there are parts still available, I believe, though it looks like this unit is discontinued. Okay, here we have the HAKKO America website, and FR820 out of stock and discontinued. And we've got technical docs and replacement parts available, so on and so forth. And part of the technical docs that were available include, these 2 are in Japanese, and there's a new FR820 document. I was on this already. Product bulletin with all this info, basically announcing a new unit, I'm pretty sure is what this document says. The -02 model, optional accessories you can get for the thing. Now, there was one doc that said, that had a bulletin about an issue with the thing. Let me see. Improved, here we go. Product bulletin. This is a different bulletin number from 2008. This is a 2007 unit, but it is the -02, so it is the revised version. Improved preheater's heating element durability, applies to the FR820. Part number is unchanged. Due to the operator usage with other SMD hot air units that usually have been set in a fixture above the FR820, the hot air stream blows down into the exhaust opening of the FR820, causing the heating element to overheat and blowing the thermal fuse. For this reason, the heating element has been redesigned to withstand higher temperatures. I believe that part is the one that's available now, and hopefully what's backstocked. Although the heating element has been redesigned to withstand higher temperatures, operation can still damage if the hot air stream is left blowing into the FR820. So it sounds like it needs good ventilation on top of all these little vent holes that are all over the place. I actually misunderstood what this product bulletin was saying. So basically, when you use SMD rework equipment and point the nozzle of your high temp gun directly down into the output of the HAKKO FR820, that will sort of cause a thermal runaway and cause the thing to overheat. You can also see that they replaced, in the upgraded version, they replaced the thermal fuse from a 76 degrees Celsius to a 91 degrees Celsius. And that number will come up in a little bit because the one that was in here was actually a higher value fuse than that. So you should see that in just a little bit. Enhance. What's so cool about it to me is that this is a product made by HAKKO, which designs these for people who service their own stuff, or at least corporations, I suppose, who are going to service their own tools or something. Anyway, it's documented well, is really what I'm trying to get at here. Includes all the stuff you get with it, including operation and options and troubleshooting. Troubleshooting and basic teardown of the thing. Doesn't go into the design of the circuit board, but anyway, I'm probably making you dizzy being this zoomed in. I'll try to reproduce what I was looking at here. I've got it plugged into power. Switch it on. Should get the pilot light. And the example was setting it at 250 degrees Celsius, and we'll hit start. One little bleep there, one little blip, and then nothing. Air starts, no heat. Let me open up the manual again. Now, something with the documentation, oh, now it's blinking. Okay, that is a sensor fault. That code there. Or, excuse me, not sensor, that error code is for blown heating element. So that's good to know. Operation, turn the temperature adjusting knob to 250 degrees C and wait until the measurement temperature is stabilized. Make sure that the temperature stabilizes, then press the start-stop button for 3 seconds. The color of the lamp will change to green. Now, I think that if it's in this error mode, it probably won't do that. Yeah. So that's just turning it on and off. I'm not able to really glean. I'm not reading this super carefully. But I can't quite tell what they're telling you that it will do until it reaches the target temperature. But what I can say is it's not getting hot at all. Okay, let's. I guess that's in idle right now, so that is heating up in theory, except not. And then it stabilizes, and perhaps the computer's expecting, "Hey, are you going to stabilize? What's going on? What's going on? Hello?" And then flashing indicates heater is blown. So I had a couple of ideas. Now, I was sort of rushing through troubleshooting this earlier. Let's stop it. Tell it to stop heating. Try a different temperature. Let's try 150. I wonder if the curve is perhaps different or something. Let's actually try 300 first. I wonder if it's going to detect, look for a ramp up of temperature. Perhaps it would be faster or something, but let's... Actually, what I should do... Still cold. I'm going to count seconds until the light goes out. That was about 16 or 17 seconds. At 300, let's turn it down to 150 and see what it does there. And that is the repeated flashing light, which is the... Double check. Heater error. When a heater fault is detected, the lamp flashes at equal intervals as shown to the left. Let's time it here, going to 150. About same, 16 seconds in it. Started doing that again. So this seems like the computer thinks that it's a heater error. And by the way, it says to leave that on so that it can cool off by air, but it doesn't seem to be getting hot. Well, I think that we can verify that the heater is bad pretty easily just by testing its resistance. Go ahead and tear this guy apart. The big reveal. Actually, let me get you a little closer. The big reveal. the heater connection is the one that goes between the heater, obviously, this little crimp here, and the sort of fan plus heater combo. This wire down to there, and that big connector. So I'm going to go ahead and disconnect that carefully. Perhaps not super carefully, especially considering all these wires have been definitely exposed to a lot of heat. It seems like this thing wasn't designed super well, or at least isn't as reliable as some of their other products, maybe. Oh, yeah, perhaps there's a latch on the bottom and you should try not to break it. Okay, it looks like a smarter move would have been to just pull the circuit board, so let me go ahead and try to do that instead of trying to break stuff on this board that I mentioned is fragile and didn't even... Let me be really hard on myself, how about that? It took a little bit of wrestling, but there's a latch on the bottom of there, so don't torque on that board too hard, is what I get from that. Go ahead and test it really quick on the multimeter for ohmage, and we're expecting range of 200 ohms because we want this to be between, check again, 25 to 30 ohms. So check across these two, can you see? Open loop. That's one. Okay, yeah, that looks like a bad heater to me. Why don't we also check out the sensor, just because we're here. I've lifted up the heating element and sensor sort of assembly here and just wanted you to see what that looks like. So that guy sort of gets sandwiched down on top of the fan. Also has a ground strap here. And basically those things have to be removed, obviously, before you lift this up. It looks like at least my heater is bad, if not my heater and sensor. Need a bit of a reminder on Ohm's law to be able to verify that. I just want to see what it does with the heating element disconnected and sensor removed. That is sensor error. Yep, double light flashing. Okay. No, it won't even spin up. Okay, or the fan won't even spin up. Excuse me. I'll go ahead and reconnect the sensor and just see if it'll at least spin the fan up. Okay, power on. Steady. Still steady. Okay. Well, let's see if it does the same thing with this head sensor hooked up. I'm not convinced that the sensor is also bad. I am confused by the 0 ohms. Like, it needs to be reading 0 ohms for the sensor to be bad. So let's go ahead and turn it on, hit start on 250 volts, and the heater is disconnected. Fan goes on. We got a little blip out of the sensor light, or excuse me, out of the status light, and we'll wait for 15 seconds. Sensor is hooked up, and repeated flashing. Here's the bottom of the heating element again. Here's our sensor wire coming out from underneath. It sort of gets fed through this little slot, I guess. And we've got the heater element wires, and I believe it comes with everything except for the plastic shroud, and perhaps this little guy right here. Now I think that guy is a thermal fuse. This engages if the entire system is overheating, something of that nature. I want to double check that now our wires here, we're testing across the heating element. So one wire goes here, one wire goes to the far side of that little can right there. Now I'm pretty sure that's a thermal fuse, and we might be able to get away with just getting a new thermal fuse. So 200 ohm scale, again we're looking for, what's it? What was the number? Was it 25 to 30? 25 to 30 ohms. So here and there, open loop. Now let's let me also just double check here. There. There, also open loop. So we can also bypass that and go straight across the contacts for the heating element and look for resistance. 29.9 ohms, which is still within spec. So I think that guy is our problem. So how do we replace that? What is that? Looks like we need one of the same size, and we need to be able to get little ring connectors onto it. Let's take a closer look at this. And yeah, okay, so our heating element, looks like we need to pull this guy out. Oh, easy, okay. So this can just pop up. This can just pop out. These wires have clearly been heated, obviously. The entire thing, they're very stiff. The little supports for the heating coil seem to be made out of like maybe mica. Is this designed to be a one-way operation? Ah, no, you just rotate it. Okay. Rotate a little bit and then that comes out. Sorry if that ended up out of frame. Here's our little heating element, and this is still available on their website, also on other online retailers, obviously. Now, I think our thermal fuse is the problem, like I said, so I want to disconnect this guy, that little guy, which on one side is going to be this crimp, and then on one side is going to be that little nut. Now, I'm a little worried about touching this filament too much because I guess I just need to make sure it sort of stays squished back on there, but I need to completely remove that screw. So if I do find a replacement thermal fuse, I think that it will be a delicate operation, and this entire assembly is, I think without the little sensor, is I think between 50 or 60 and 70 bucks. It would be nice to not have to pay that. I'm noticing that this, I think, is the sensor wire. Like I said, we know this is the sensor wire, and the sensor is way up here, right there. I think it snakes through the middle of that and is sort of hovering above, so that's where it's getting the temperature readings from. I think they'd like me to, I mean, this is a good discontinued product. They want me to replace this into a whole assembly, and I haven't yet figured out if the thermocouple is part of the assembly. I think it's not. I think you have to like sort of disassemble this thing and thread it out and maybe thread it into the new one. I'm not sure. There we have the replacement part. It's A1537, which is 70 bucks. Looks like we got the heater cables, the things that actually get the heater heated up, and then it looks like the thermocouple is actually already attached right there. So this part, A1537, 70 bucks, and it replaces the sensor and the heater. So I think it's weird, not weird exactly, but that they let you troubleshoot the heater and also the sensor, these two parts, in one. Or excuse me, this replacement part is sold as one unit, but they let you test each individually, which is kind of interesting. I guess that if either of these fails, it means that the entire system the entire part is blown, which isn't really a problem. For cheapskates, it might be. Is that 165 thousandths? Yeah, 165 thousandths wide. And sort of generic, it's really the only thing I need to worry about is that it needs to fit within that thing. Double check. And the channel itself is 177 thousandths wide. So, in theory, with the little bits, like that little, on the end of the can, the little spade, or not, a little ring connector there, which goes to the side of that, and a crimp, a high temp crimp, though that may not even need to be high temp, it probably should be high temp, and a fuse of that diameter, I think I might be okay. Hold up. Or is the width the word I'm looking for the thermal fuse? It needs to be that width at the very least, and be able to stick into the base of this thing. I went ahead and removed the thermal fuse just because it was going to have to happen anyway. With these types of connectors, you can sort of squeeze them gently, well, not gently, using a wire stripper multi-tool like this. And I just put it in the 12 to 10 gauge, and I squeezed against the sort of fold there until I either felt it rotate away from that, like that, at which point I'd release off a little tension, rotate it in the opposite direction, try squeezing again, until it basically released enough that I could wiggle part of the heating element wire. This is the wire going to the heating element out of there. Notice that it's not it's stranded, but it's not twisted, and it's also sandwiched right up next to this guy. And I did grab I began grabbing some of the data off of the part itself, but I'm gonna, just now that I've actually got it out, it was too difficult to read and try to make guesses of what it says. So this way I'll be able to just hold it up, compare right with what's on my computer screen, and then find the part, hopefully. That's the spec that we want to meet. Here's the old thermal fuse, and I went to an electronics store nearby, and they had several of them in stock, so I was able to get a couple. Now, the problem is they're not exactly the right ones. These are same size, same shape for the most part, similar enough shape. Measurements say it should fit in the same recess that this one it was in, but they are thermal cutout for 93 degrees Celsius, not 94 degrees Celsius, like that one was. So I bought two of them just in case, you know. I don't really know the best way to think about this, because it is a safety device. I don't want to, you know, break that really. So I'm wondering if the way that this thing received its, you know, measurement temperature is that this was the spade that went onto the heating element itself, and then this went onto the crimp. So the heat was coming down this, and then once this thing reached 94 degrees Celsius, it would cut out. This is a lower temp fuse, so potentially I may not be able to run this thing as hot as it used to before the heating element goes out, like it did after however many years of use the first time. So yeah, that's not really a problem, I don't think. There's our thermal fuse. Came with these little lugs. Not entirely sure what those are for, and also some instructions, which is kind of a rarity for electric components, it seems like, or I feel like a lot of the times it is. I'll go ahead and just share that with you there, and I'm going to give it a read over. Replacement techniques. When replacing a thermal cutoff with a trip temperature less than 120 degrees Celsius, the replacement should have a trip temperature within 4 degrees Celsius of the original. So that is a check mark for this, because this was a 94, that's a 93. Let's see what else. Looks like there is it matters what end is going onto what. So there's the seal end, which has the resin on it, and then there's the cap end. Case end, perhaps, is what they call it. Has recommendations on how to bend it properly without damaging it, because apparently they're physically sensitive as well. As well as you need to pay attention to heat flow. Here they're actually showing it with a replacement nut and washer. I didn't have one of the right size, and I don't want to solder because soldering can also, I think, preemptively trip these things. So I have more or less just bent a replacement out of the same. So there's the two next to each other. The bend is approximately the same. And then we can reuse the little guy on the end here. And then if this blows again, then I'll probably need to find another one of these, because I don't really see these things last many more than one extra use than after their initial. But I'll go ahead and trim this guy a little shorter. And we should be good to go ahead with the install. Sticking up still. I'm going to unwind it a tiny bit, make it a little bit longer, and then put it back in there. Okay, I think that's going to be enough. Just going to let it right over there and sort of squish it down a little bit and hope that it doesn't damage it. Okay, that should be fine. Alright, well, I've reassembled the thing. Off camera, I tested the resistance of the heating element, like the instructions showed that we went over earlier, and it's now reading 29.9 ohms. So I'm going to go ahead and grab a power cord and see what this thing does. Steady light. Let's turn it towards you a little bit. In fact, I'll even put it on an angle so maybe you can see it a little better. And we'll just start it at 250. Awesome. Oops. So it glowed very brightly, and then perhaps now it's modulating. Yeah. You can see it pulsing. Check that out. That is pretty nifty. And I'll go ahead and start and stop it with you over the top so you can see what I saw. Stop. Presumably it's going back down to cooling itself back off because the fan is still running. And we'll hit start again. Again, this is at 250 degrees Celsius. Wong. Sweet. And then I think it's regulating now. When it's blinking like that, it's regulating. I think that the pulsing of the LED is actually the same as the pulsing of the coils inside there. So, this is really good news. Now, this thing broke because it overheated in the first place. So I think that, importantly, for me to be able to continue using this thing, airflow is going to be super important. Now, I'm also kind of concerned because the max temperature of this is 572 degrees Fahrenheit, 300 degrees Celsius. And I wonder if that will cause issues with, excuse me, let me rephrase this. I wonder if using the wrong value thermal fuse will make this more difficult for me to use it at those higher temps, like maybe it'll blow again. Let's go ahead and try it out. Let's go ahead and set it at 300, hit start. There it goes, glows on. Starts flickering and modulating. I also assume that on the fly you can turn it down to 250, it stops pulsing. Okay, perhaps it's only the light is on when it's not heating the coils, because when we ramped down, it stayed on for a little bit, like that. All the way down to 150. Stays on, it's blinking a lot less often now. Or it's, the blinks are shorter, it seems like. Let's crank up the heat. That's so cool. All right. Well, I kind of want to do a little board rework now. Shit. I'll see if I can set up a little jig, and maybe we can get some footage of that.